drift of electrons and the origin of resistivity. Now see, suppose we consider any ith electron, which one is executing random motion in the conductor. All the electrons are executing random motion, but we consider here any ith electron, and suppose its velocity at any time t, that is vector vi, and total number of electrons in the conductor are suppose capital N. So here, if we think about the average velocity of the electrons, then we have to take the vector summation of the velocities of each and every electron, and then we have to divide it by total number of electrons. But here electrons execute random motion. So when random motion is executed, it implies that the probability of the electron to move in any direction, that is same one. So when we take the average, then average velocity of the electrons, that will come to 0. Clear to all of you? So we can write sigma I equal to 1 to n vector vi, that is the summation of the velocities of the electrons, and when it is divided by n, then we can say that is the average velocities of electrons, and that comes to 0. Clear up to this one first? Now see, we discussed this thing, the average velocity of the electrons in the conductor, that is 0. But that is the situation when the electric field is not present. But suppose we consider the presence of electric field in the conductor. Now, if electric field is present, then we know this thing, when any charge Q is placed in the electric field, the force acts on it, that is Q into E. So, when force acts on the charge, definitely it will be accelerated. So here, the charge particle, that is electron. So electron will experience the force F, that is minus E into capital E. So in the presence of electric field, the electron will be accelerated, and we can write acceleration of the electron, that is minus E upon mass of electron. Now, velocity of electron after collision at any time t, that we can calculate using the equation V equal to V0 plus AT. So at any instant t after collision, the velocity of electron, that we can write V, that is equal to initial velocity of the ith electron we considered, that is Vi, plus acceleration, that is minus E upon me into t. So average velocity of electron, that is Vi average minus E upon me into tau. This tau, that is known as the relaxation time, that is nothing but the average time between two successive collision. Because here the velocity is taken average, so time, that also we have to take average. So tau, that is the average time between two successive collisions. But we already discussed this thing, Vi average, that is equal to 0. So simply we can write V average, that is minus E upon me into tau. And this V average between two successive collision of the electron, that is called its drift velocity. That is called its drift velocity. So we can write drift velocity Vd, that is equal to minus E upon Me into tau. Now see, here let's think about the physical interpretation of this one. See this figure. Suppose initially the electric field is not present and the path of one electron is represented here, that is A to B. A to B, the electron move. But when the electric field is present, then in the opposite direction of electric field, the electron will experience the force. Now, under the effect of force, suppose the path of the electron that becomes A to B dash as represented by the red dotted line here. It implies that due to presence of electric field, your electron is drifted, or we can say dragged, from B to B dash. So the velocity of the electron during this displacement, that is its drift velocity. So due to presence of electric field here, no doubt electrons suffer so many collisions, but resultantly its tendency, that is to move in the opposite direction of electric field, and therefore some net charge will flow through any cross section of the conductor, and this drift velocity, that is the reason for the constitution of electric current. Clear to all of you? Now, resistivity. Suppose here, as shown in the figure, we consider one conductor having cross-sectional area that is equal to A, and in this conductor, the electric field that is in the direction as shown in the figure from right to left. So, drift velocity of electrons, that will be in the opposite direction of electrons. Now, here suppose we consider any cross section of the conductor. Here in the figure, that cross section is represented as this dotted line. Now, total number of electrons passing through this cross section in time interval delta t with drift velocity Vd, that we want to find here. Okay. See, very first electron which one is passing through this cross section with velocity Vd, that will cover the distance equal to Vd into delta t in time interval delta t. And suppose that distance is Vd delta t as shown in the figure. So here at Vd delta t, we consider another cross section at the distance Vd delta t as shown in the figure. So we can say all those electrons which are passing through this first cross section in time delta t, all will be accommodated between these two cross sections in the conductor. Now, suppose we consider the number density of electrons in the conductor, that is small n. Number density means what? Number density means the number of electrons per unit volume, that is equal to n. So if we calculate the volume of this much part of the cylinder, means if we take the volume of the cylinder having length Vd delta t, then we can calculate the number of electrons passing through this cross section in time delta t, because all those electrons are accommodated in this volume. Now, number of electrons passing through any cross section of the conductor in time delta t, that is equal to volume of this much part of the conductor, that is Vd delta T into A, and multiply it by number density of electrons. So that is N into Vd into delta T into A. This is simple unitary method. Per unit volume, the number of electrons, that is N. Therefore, in the volume, Vd delta T into capital A, the number of electrons are how much? So, total number of electrons passes through any cross section of the conductor in time delta T, that is this much. Clear up to this one? Now we have the total number of electrons passing through any cross section in time delta t. So we can say the amount of charge passing through any cross section of the conductor in time delta t, that is the number of electrons into charge of electron. So we can write that is equal to N Vd delta T into A and multiply it by charge of electron, that is minus E. Now, this much amount of charge that is flowing in the opposite direction of electric field. So we can consider the amount of charge flowing in the direction of electric field, or in other words, we can consider like that the opposite charge flowing in the direction of the electric field in the same time interval delta t, that is delta q equal to plus NEVD delta t into A. Clear up to this one? Now current I constituted, that is equal to delta Q by delta T. So in this equation, take delta T on left hand side. So you will get delta Q by delta T, that is NEVDA. Now suppose we take A on left hand side, then we will get I upon A, that is NEVD. But I upon A, that is current density J. So we can write J, that is NEVD. This one identity that is also very important. એટલે મેં અહીંયા બાજુમાં લખી એને. Now rewrite this equation, take A on left hand side. So I upon A, that is equal to NE. And now substitute value of VD, that is E upon M into tau. So we can write now I upon A, that is current density J, and E into E, that is E square, into capital E upon M into tau. In vector form, if you want to write this equation, then you can write vector J, that is NE square upon M, vector capital E into tau. Now, we discussed Ohm's law in vector form. In that, we discuss the equation J, that is sigma E. So here J, that is replaced by sigma E. That is equal to NE square capital E into tau upon M. Now capital E cancelled. So sigma, that is equal to NE square upon M into tau. Sigma, that is called conductivity. Reciprocal of conductivity, that we can say resistivity. So here we can write the equation of the resistivity, that is M upon N E square tau. And This equation of the resistivity suggests this thing: as temperature increases, the resistivity also increases. Clear up to this one? Now see here. Actually, in this equation of the resistivity, temperature is not appearing. Okay. Now, we say this thing: as temperature increases, the resistivity also increases. Why? Because as temperature increases, the kinetic energy associated with the thermal motion of electrons also increases. So the motion of electrons becomes speedy. And if motion becomes speedy, then number of collisions in a given time interval increases. If number of collisions in a given time interval increases, then time between two successive collisions, this tau, decreases. And now in this equation we can understand, if tau decreases, then resistivity increases. Clear? Example 3.1. A. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1 into 10 raised to minus 7 meter square, carrying a current of 1.5 ampere. Assume that each copper atom contributes roughly one conduction electron. The density of copper is 9 into 10 raised to 3 kilogram per meter cube, and its atomic mass is 63.5 U. B. Compare the drift speed obtained above with thermal speeds of copper atoms at ordinary temperature, and 2. Speed of propagation of electric field along the conductor which causes the drift motion. Now see, here the information given to you, that is about area of the cross section 1 into 10 raised to minus 7 meter square. Conductor is carrying the current I, that is equal to 1.5 ampere. Density of the copper that is given to you 9 into 10 raised to 3 kilogram per meter cube, and its atomic weight that is 63.5 gram per mole. Now we have the equation for drift velocity, that is J equal to NEVD, but J that is equal to I upon A. Now we want to find the drift velocity, so make VD as a subject of equation. So VD, that is I upon NEA. I that is given to you, A that is given to you, E is always given. But here the number density of the electrons that is not given to you. So that we have to calculate. See, the atomic weight that is 63.5 gram per mole. So we can say per mole the number of electrons, that is 6.02 into 10 raised to 23, because it is given to you in the question. Per atom, one electron is contributed. So the mass equal to its atomic weight 63.5 into 10 raised to minus 3 kilogram. The number of electrons, that is 6.02 into 10 raised to 23. Therefore, in 9 into 10 raised to 3 kilogram, how many electrons are there? Now this particular mass 9 into 10 raised to 3 kilogram, that is the mass per unit volume. And in this mass, when you calculate the number of electrons, impliedly it is the number of electrons per unit volume. Now calculate this one. You will get the number density of electrons, or we can say number of electrons per unit volume. Clear up to this one first? Now substitute the value of INEA in this equation of VD. So I, that is 1.5, E, that is 1.6 into 10 raised to minus 19, and area, that is 10 raised to minus 7, and whatever the value of N is calculated, substitute it here and then solve. You will get VD. Okay. Now the velocity associated with thermal motion. So in standard 11th, we studied this thing. The kinetic energy of atom, half mv square, that is 3 by 2 kbt, where kb, that is Boltzmann constant. So v square, that is 3 kbt by m. So v, that is under root 3 kbt by m. 3 kb, that is 1.38 into 10 raised to minus 23 into temperature, that is 300, and mass of the atom. So of 1 mole, the mass is 63.5 into 10 raised to minus 3. Divide it by total number of atoms in 1 mole. So that is 6.02 into 10 raised to 23. And when you solve this one, you will get the answer 2 into 10 raised to 2 meter per second. So this is the velocity associated with thermal motion. Now we want to compare the drift velocity with thermal velocity. So take the ratio VD to V. VD we calculated here, and V, that is 2 into 10 raised to 2 meter per second. You will get the comparison. Then speed of propagation of electric field, that is the speed of light, that is 3 into 10 raised to 8 meter per second. So now to compare drift velocity of electron with the speed of propagation of electric field, take the ratio VD to C, you will get the answer. Clear to all of you?